Hi there and welcome to this beginner's Plaxis tutorial for designing a tunnel. So I wanted to make this Plaxis tutorial because quite a lot of the other tutorials out there just really weren't great, and you know, a lot of them didn't even have any audio description. It's just someone clicking on a screen. So I wanted to create this for you know, for a better quality of video really. So before we get started, I just want to give a shout out to the sponsors, who are Tunnels AI, who yeah, it works quite well with Plaxis because these guys, it's all free to use. It's like a community project, and you can actually use these different tools that they have to predict tunnel lining designs. So you can go ahead and input a tunnel lining diameter here, and it uses artificial intelligence to predict your tunnel lining design. So it would come out with predictions on thickness, number of segments, ring lengths. They're very useful. So yeah, so let's get started with the tutorial. So a little bit about me before we actually fully get started. So I'm a tunnel engineer with about 8 years of experience. I've used Plaxis on several different projects. So yeah, this is a very quick 10-ish minutes on an introduction to Plaxis. So let's get started. So when we create a new model, we're given this screen here. So here we're going to set up our model dimensions. So we're going to say for this tunnel, it's going to be 50 meters is the starting x coordinate, minus 50 meters and plus 50 meters. We're going to set this as the minimum bounds of the model. So here we're going to set this as the overall model is going to be 40 meters deep. I'm going to start it at 0, y. Oh no, let's say 10. We're going to start it at 10. Don't worry about the others for now. So here we've got our model space set up, and what we're going to do is we're going to create our first borehole to get started on creating our geology. So here we open up the borehole window. So what we can do here is we can actually add materials in here. Before we do that, we're going to go down to this one here. We're going to actually create our materials which represent the soil. So here we open up our material sets, and we're on soil and interfaces. So we're going to create a new soil. So we're going to call this one sandy silty clay 1, and we're just going to set this up quite quickly here. So we're setting our density here as 20, but obviously you're going to set all of these properties based on what your SI data is. I'm going to set this as 300 to the 6 to the 3. I'm going to set this as 0.3. Setting the cohesion. So these are just like some roughly standard properties for this sort of clay. Leave these as the same. Ignore these for now. Come back to those in some other tutorial perhaps. And we're going to set up here our K0, so say like 0.75. Okay, we're going to go OK now. So we set up our first soil. We're going to do 2. And then we're going to set up our next one, sandy silty clay 2. And make this 20, 20. We're going to give it like slightly different properties just for interest. Make this 0.25. Yeah, there we go. Now we've set up our 2 soils in here. So now what we're going to do is we're going to take these and we're going to create our geology in this borehole we have here. So this is borehole 1. We've got up top of the borehole is 0 at the moment, and the head, which is the groundwater level, let's say at 0. We're going to add these 2, so we're going to add 2 layers in here. So our model's 40, right? So we're going to create one which is 0 to 20 meters below ground level, and then we're going to create another one which is from minus 20 to minus 40, which takes us to the bottom of our model. And then we're going to assign our different clays. So this is the weaker one too, so we're going to put that on the top, and then the stronger one at the bottom. And then let's say our groundwater level is 1 meter below surface level. And now we set up our 2 soils. So we're going to click OK now, and we can see that this has been generated, our section showing the soil. So we've more or less finished with the soil tab now, so we're going to come across to structures. Now when we're in our structures, we need to, once again, we can go down here to material properties. So there's different ways of doing this. Some people like to work from these ones. I like to use a mix. So we're going to go down to here. We're going to go to plates now. So we're going to set up our tunnel lining as a plate. So here we're going to call this like 300mm thick lining. And we're going to set our properties here. So I'm just going to bring these some standard properties in. So, but something like Tunnel's AI is good for predicting roughly what these should be. So we're going to put this as, let's say 8.4 e to the 6. So this is Young's modulus times area we have there. And then here we have Young's modulus times second moment of area. So these are the ones that we need to input. So we're going to put this in here. Yeah, that's okay. And then what we want to do is we want to check that D here is our thickness in meters. So this is 0.3 meters, so that's okay. And then let's just put this in. I'm not sure if this is correct, 1.8. We'll put that in there. 0.25. Okay, so we've set up our lining thickness now. Right, there's other things that we can do here, but we're gonna keep this simple. This is our lining. So now we're gonna create our tunnel. So let's just like position it down here, -31, so it's in the strong stuff. And yeah, so we use our tunnel creator over here, and then this opens up our tunnel design window. And we have different settings in here, but what we're going to do is go to shape type. We're going to go circular because we're going to have a TBM segmental, TBM driven segmental line tunnel here, and we're going to define the whole tunnel. We're not going to do any kind of offsets or anything for this. And now what we have is we have our segments in here, which we're going to set the radius for. So let's set this as like 3 meters. So it's going to be a 6-meter diameter tunnel. So once we've set this up here, we can see that this is updated, so we're at 0 to 6. So that's worked. You can also set subsections like individual segments, but we're also not going to do that. So now we come across to properties. So here's where we actually have to set some properties for our tunnel. We need to get this is quite important, so we need to get this right. So we're going to create a plate here. We're also going to create a negative interface, which is to do with this interface between the lining and the ground. And we won't go into that in much detail today, but we need to add that. And we're going to set our plate down here as 300 thick lining. But we can also go here and we can go plate, and we can set the material in here as well. With Plaxis, there's several different ways of doing the same thing. So now we have our tunnel in here, and what we can do is we can hit generate, and that will generate the tunnel within our model. So we can see roughly this is, but let's put this in the center of our model just for you know, for like consistency. So we're going to select our tunnel in here. We're going to put this as 0 just so it's nicely centered. At -31, so that's the point at the bottom, so that will be -31 there if you need to calculate your exact position. Now we're going to go over to mesh. So people like to do this in different ways as well, but I like to normally do this as very fine or fine. We're going to set it as fine for this model, but what we need to do is like make sure that if the tunnel is closer to this interface, or if there's another tunnel in here or something like that, we want to make sure that the mesh generates nicely and that we have several different nodes and elements between them. Like, you don't just want one. If this was closer to here, you don't just want one in here. You want to see quite a few. So the mesh is nice and tight. So we're just going to have a look at our mesh once this generates. Make sure it's okay. We also have up here, we have flow conditions, which is more like groundwater, but we don't need to do that. So after this stage, we can move straight on to our stage construction. So yeah, you can see within the tunnel, we've got a nice mesh. We've got enough mesh up here, so looks okay to me. What some people can actually do is you can actually create a box around this and refine the mesh in there if you need to, rather than refining the whole thing, because it can slow the model down. So here we're on stage construction. So what we need to do in this stage is actually model our tunnel lining being installed. So we're going to say, like, we have our initial phase in here, which is turning on the soil body and allowing it to settle down and then reach equilibrium. And then what we want to do in this next stage is we want to make sure that our displacements are being reset to 0, because when we've allowed this soil body to settle, we're not interested in what settlements resulted from that or from anything else. Like what we're interested in is it relating to our tunnel construction in this example. So in this stage, we're going to go tunnel lining plus excavation. Or the other way around, actually. We're going to say excavation plus tunnel lining. So we're going to go, I guess that comes first. And we're going to then excavate this, and we want to turn the soil off and also set the conditions within the tunnel to dry, and then activate our lining. And we're going to go right ahead and just run this before I show you one or two other things. So sometimes with bigger models it can take much longer to run this stage, but this is fairly simple, so hopefully it shouldn't take too long. One of the things that we haven't done here is we haven't added a line load at the top. So what you can actually do here is you can include a dummy element with very low stiffness and attach a line load to it. And quite often that's needed because you are going to have some developments or some loading on the ground surface level, which you need to consider for the tunnel. So what you're going to see with this is some deflection of the tunnel lining. But what we haven't done here is so here we can start looking through our different results. So what I did there was I ran the model, and then I've come down here to view calculation results. And when we're in here, there's a lot of different checks that we can do to this, but I've actually ran this and it's not going to be correct. You can see that this is completely wrong, actually, in the sense that what you want to see is a settlement trough above the tunnel, and we're not seeing that. And instead what you're seeing is some heave, because we've set this to dry and what is submerged in water. So what we're having is the tunnel lining the tunnel itself actually trying to float up. But this isn't correct, because what we need to do is we actually need to so this is one of the first checks to do. I'd like to look at the settlement. So one of the first checks that we're actually going to do here is one of the extra things we're going to do is we're going to add another stage in here. And before we do that though, we're actually going to need to come back to our tunnel in here, and we're going to have to go to edit, and we're going to want to add something called a line contraction. So we come here and we're going to go to create, and we're going to go to create line contraction, and here you have this cref. And so what this is actually going to do is it's going to pull this circumference of the tunnel in by a certain percent. It's going to reduce the length of this line. And what that's actually doing is it's going to, so if we set this as 1.5%, let's say, to start with, what this is actually going to do is it's going to, when that line contraction is applied, it's going to pull all the soil towards this. And what that actually means is that we're going to, when the TBM is excavating this tunnel in here, it's not going to be perfect. You're going to have a slight amount of over excavation beyond the profile of the tunnel, which you're going to fill with grout, but it's still not going to be perfect. So what you end up having is like a slight amount of soil being lost than you actually need to. And that percentage, so I set that as 1.5%, but it's not directly linked. It's not, the volume loss does not equal the line contraction. You have to calibrate the line contraction by looking at the settlement at the top. But that's a more advanced feature, but just to be aware that you need to consider this line contraction. So here we have the line contraction turned off in stage 2, which we've already run. But what we need to do in this extra stage is we need to consider the volume loss, which is going to create our settlement trough which is realistic. And now, before we rerun this, we're actually going to change the line contraction very slightly, because I have a feeling it's too high. So we're going to go here, we're going to go to properties, and we're going to go to 0.5%. We're going to change this to 0.5%, so it's a bit less. Because otherwise I'm worried that this will be it'll be too great. It will, like, the soil will you'll need too much stress for the strain that we need. So we'll regenerate the mesh, and we're going to rerun the model and see what the results look like. So what we're hoping for in this case is that we actually have a proper settlement trough. And then I can show you briefly how we actually look at the lining forces very quickly. And there's some other checks that we can do here. Actually, what we could do is create a we can create a surcharge on top here, because quite often you'll have some developments on top of the tunnel. We won't do that today, but you can actually create a line in here and add a dummy plate in there, and then you'll create a line load on top of like 25 kPa, for example. And that can change your results, so the force acting in the lining. But that's for another day. This is just to get a basic tunnel lining check done. So now we're going to open up, and what we're looking for in the results is so we still have our settlement open, and what we can see now is something much more how we'd expect. So we've actually got the settlement trough generated here. We have negative settlement, so you can see red is negative, and we're actually seeing that here now. So this is much more reliable. And there's some other checks that we can do in here. So we can actually create we can select our tunnel lining here, and this window will pop up. So we're going to go plate. We're going to select that with enter. What we're going to see here is our deflection of our lining. We can see our axial force. So this is the compression of the lining, so 889. We can use that for our design checks. You see our bending moments here. And then if you're using spreadsheet methods, what you might want to do is you might want to go to this table, and you can select everything with Control A, Control C, and then you can copy this into your spreadsheet. You can use this to create your MN plots. And so that's a quick, very fast description of a way to model a tunnel, a TBM driven segmentally lined tunnel. And yeah, if you have any questions or any specific problems, just put them in the comments below, and I'll do my very best to answer them all. So hope you enjoyed this, and please like and subscribe.